Hey guys, welcome to 7.1. Chapter 1 and Section 1 have the same title. We're going to be discussing probability in Chapter 7. And very closely related to probability is statistics. And we'll be talking about statistics this chapter as well too, and how that kind of relates to probability. Probability and statistics are a field that has a lot of real life applications. A lot of businesses really are interested in statistics and probability of a lot of different pieces of the puzzle to their business. One of the most common ones that I've seen, I'll give you an example, is Amazon. You've maybe seen those Amazon Web Service commercials where they talk about probability and how they use that to benefit their company. I'll show you an example here to start.
See the stats on that one. I get the handoff, and with four defenders that close, chance of punching it in for a TD, 14%.
You could hear him talk about probability right there.
Work with that, so I accelerate a lot. Defender distance, decimals. My only out, zero gravity, 6 points. Best flip and play of the season. Next gen stats powered by Amazon Web Services, AWS.
So, you hear him talk about probability there and statistics, and this is stuff that Amazon is using right now. And it's we'll just cover the basics today, but you can see that this has some applications to the real world and to a lot of businesses that want to know more about how they're making money and more about their consumers and more about their shipping, and you could go on and on and on. For our learning target today, we have, I can use relative frequency to describe the likelihood of an event. Right. So how likely something is to happen. When I hear that, I think of the likelihood. When I hear that, I think of like weather. I always see things on the Weather Channel like, oh, there's an 80% chance of snow today. Right, or rain, or whatever it might be. You see those statistics and those probabilities all the time in the Weather Channel. All right, let's get to our key idea. We got some vocab words here that I would highlight or circle if I were you. It says an experiment. You've probably heard of this before. It's in science as well. That's an investigation or a procedure that has varying results. The possible results are called outcomes. Okay, so anytime you conduct an experiment in science or in math or even outside of class, there are different results, and those are called outcomes. A collection of one or more outcomes is an event, and the outcomes of a specific event are called favorable outcomes. Right? That you've probably seen a little bit of this before, but maybe just didn't put specific vocab words to it. And we'll go over examples of each of those as well. For example, randomly choosing a marble from a group of marbles is an experiment. Each marble in the group is an outcome. So these are all the different possible outcomes. You reach your hand into a bag and you could maybe pick the green one or the yellow one or whatever. Those are different possible outcomes. Selecting a green marble from the group is an event. Okay, so choosing a green marble, and there is the event. And how many favorable outcomes are there? Well, there are 2 green marbles, so there are 2 possible favorable outcomes. All right, let's check out an example using a spinner. You spin this spinner. Letter A says, how many possible outcomes are there? So how many total outcomes are there? Well, let's just start here. I could spin this red one. I could spin a blue 3. I could spin that red one. I could spin a green 4, another red 1, and lastly, I could spin a purple 2. So how many outcomes are there? There are 1, 2, 3, 4, 5, 6. There are 6 possible outcomes. There are 6 different places that you could land on the spinner. Letter B says, what are the favorable outcomes of spinning an even number? Okay, so looking at this, 4 is an even number and 2 is an even number. So the favorable outcomes of spinning an even number are spinning a 2 and spinning a 4. Those are the 2 favorable outcomes. Because these other ones are not even there. Those are odd numbers. Okay. And lastly, letter C asks, in how many ways can spinning a number less than 2 occur? How many ways in spinning a number less than 2 can occur? Okay, well, I've got, so 2 is not less than 2. 2 is 2, so that doesn't work. 3 is not less than 2, and 4 is not less than 2. So I've got 1, 2, and 3 different ways. A number less than 2, well, I can spin 3 ones, so it can occur in 3 ways. Any of those red ones that I land on would work. Okay. Let's try a few like those on your own here. Please pause the video now. All right, let's go over these and see if you got them right. It says you randomly choose one of the tiles shown from a hat. So maybe you're playing Scrabble or something. How many possible outcomes are there? Okay, well, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes. What are the favorable outcomes of choosing a vowel? Okay, here's a vowel, so I could choose this A. I could choose, here's an E, that E, or I could also choose the last A right there. Those are my favorable outcomes because those are the 3 vowels. And then lastly, in how many ways can choosing a consonant occur? Well, consonants are not vowels. So that would be my non-circled letters here. So D, C, B, B, and B here are all consonants. And how many ways can that occur? 1, 2, 3, 4, 5 ways. Okay. Let me know if you have any questions on those. And we'll move on to our next key idea, where we talk a little bit about probability. Vocab here, it says the probability of an event is a number that represents the likelihood that the event will occur. Probabilities are between 0, you can see that here, 0 and 1, including 0 and 1. The diagram relates likelihoods, so these are the likelihoods up here, the word examples, and probabilities below the diagram. So probabilities would be like they can be represented by a decimal or a percent, but you can see right here that they're the same. 0.75 is 75%. One out of one whole is 100%. 0.5, right? So that's, they're just relating those things. If there's a 0% chance that it can happen, well, the likelihood is, well, it's impossible. Or if there's a 100% chance it's going to happen, it's for sure certain. Okay. So for example 2 here, it says describe the likelihood. And kind of like I said to start the lesson, I really think about weather when I'm thinking about likelihood. It says there's an 80% chance of rain, a 50% chance of thunderstorms, and a 15% chance of hail tomorrow. Describe the likelihood of each event. So when I see likelihood, I'm thinking about all of these terms up here on our probability scale. Okay, so 80% chance of rain. Well, it's not certain. It's not all the way 100%, but 80% would be really close to 75%. So the likelihood would be that it's likely. I'm just matching it to the word up here. It's likely to rain tomorrow. Letter B says there's a 50% chance that there are thunderstorms tomorrow. Okay, well, 50% lines up right here. So that would be equally likely to happen or not happen. Right? It's 50%. You might hear people say a lot of times, well, you got a 50-50 shot, meaning that well, it's either likely to happen or it's the same likelihood to not happen. It's 50-50. And then lastly, for letter C, there's a 15% chance that it might hail tomorrow. So, well, it's not zero, so it's not impossible, but it's 15%, which is pretty close to that 25% chance. So it is unlikely. We're not saying it's impossible, right? It's not a 0% chance, but it's not very likely. It's unlikely to happen. Okay. So I'll go ahead and try 2 and 3 for the try-its here and see what you think. Please pause the video now. All right. Let's see what you came up with. Number 2 says the probability that you land a jump on a snowboard is 1/10. Well, 1/10 is the same as if I change this to hundredths by multiplying by 10 on top and bottom. That'd be 10 out of 100, which is 10%. If I go up here and look at where that falls on this scale, well, it's not impossible. It's not 0, but it's not very likely. We would say that would be unlikely. That might be impossible for me. That might be 0% chance for me, but maybe for some of you, your percent is higher. And number 3 says there is a 100% chance that the temperature will be less than 120 degrees Fahrenheit tomorrow. Yeah, I would say that's true for here in Wisconsin right now too, for being the end of February. There is a 100% chance. Well, 100% chance is certain. I am 100% sure, and I am certain that the temperature will be less than 120 degrees Fahrenheit tomorrow. All right, last thing that we need to discuss is relative frequency. And relative frequency might sound like a confusing term, but you can think of it as a measure of probability. So it's kind of like finding a percent, actually, so it's not that hard. It says when you conduct an experiment, the relative frequency of an event is the fraction or percent of the time that the event occurs. So to find it, you just take the number of times that the event occurred and you divide that by the total number of times you tried the experiment, or that you conducted the experiment. So here's a really good example of that. I know bottle flipping was a huge thing like a couple of years ago, but maybe it's still fun to try it once in a while. But it says you flip a bottle and record the number of times it lands upright and the number of times it lands on its side. Describe the likelihood that the bottle lands upright on your next flip. Okay, so here we conducted an experiment and it landed upright 2 times and it landed on its side, let's see, 5, 10, 15, 20, 21, 22, 23. So the total times that we flipped our bottle would be 25 total, right? Because it's 23 times it landed on its side plus the 2 times it landed upright. That'd be 25 total times. Remember, to find the relative frequency, we take the number of times that the event occurred and divide it by the total number of times that you conducted the experiment. So we found our total. What's the number of times that the event occurred? What are we looking for? Well, we're trying to describe the likelihood that the bottle lands upright on your next flip. So it landed upright 2 out of the total 25 flips. Okay, so now it just wants us to put that as a percent. Well, that's That's not too hard, right? 2 out of 25. If we get that to 100 by multiplying by 4, that would give us 8, right? Times 4 on bottom, times 4 on top. It gives us 8 out of 100, which is 8% chance. So if I'm thinking about the likelihood that that's going to happen on my next flip, where does 8% fall in here? Well, it's pretty close to impossible, but it's not 0, so it is unlikely that bottle is going to land upright. And you can see that pretty clearly from the data. Most of the time it's going to land on its side. Once in a while you might get lucky and it might land upright. Okay, go ahead and pause here for the last try. All right, number 4 says you attempt 3-point shots on a basketball court. Ooh, I like that. And record the number of made and missed shots. Describe the likelihood of each event. You make your next shot. So, shots made. How many shots did I make? Let's see, 5 plus 4 is 9 out of the total. Well, if there's 9 here and there's, let's see, 6 here, what is 9 plus 6? Well, that would be 15. So you made 9 out of a total of 15. What is that percent chance for 9 out of 15? Well, if you can just take your calculator here, 9 divided by 15 gives us 0.6, which is 60%. Okay, if I go up here to my relative frequency, is 60% closer to likely or equally likely to happen or not happen? Well, that would be equally likely to happen or not happen. So I'll just shorten this up as equally likely. And let me tell you, if you're shooting the 3 ball with 60%, you're a really good shooter. Most people's 3-point percentages, if you're a good 3-point shooter, is like 35 to 40% is what we consider pretty good in basketball. So if you are shooting it at 60%, wow, you're a really good 3-point shooter. And letter B says you miss your next shot. Well, okay, I had 6 misses over the total of 15. So take 6 divided by 15. Well, that would just be 40%. If we know 9 out of 15 is 60, those together should make, right? 9 plus 6 is 15 out of 15. So 40%. And what is that close to? Well, similar to before, 40% is closer to 50% than it is to 25. So we'll just say equally likely as well for that one. Oops. Pretty close to 50%. Alrighty, so there you have it. That finishes up with probability and statistics. A lot of real life applications here. We'll get some more practice in soon. Thanks for checking out this tutorial. I'll see you guys next time.